Hi, welcome to video 10. In this video, we will learn Introduction to Java IO, Understanding Java IO Package, Writing Java Program with File Class, Java Program to understand Reader classes with BufferedReader and InputStreamReader, Writing Java Program with Writer classes with BufferedWriter and FileWriter, Understanding Serialization and Deserialization, Implementing serialization and deserialization, output stream classes and input stream classes, output stream classes with object output stream and file output stream, input stream classes with object input stream and file input stream. We'll just take it further with one more discussion, which is called as IO. So IO, which is IO. Or in a simplest term, we'll call it input and output. Okay. So probably people coming from C and C++, I'm sure that we would have seen this statement. Main, I'll say int x, print f, enter a value. Now, do we also remember we tried using something called a scanner? Now, printf entered is %d, I'll say x. Perfect, fine. This is very good. This was our first few programs of our C, or probably C++, no, whatever you say. But the whole idea here is something called a scanner. But in the entire journey of our Java, we did not do something called a scanner in the first few classes, right? But we want to do this now. Now, scanf here, when it comes to C and C++, it's a function. If you just look at this once again, there's a function which takes the first parameter as string, the second parameter is pointer. So if you again go back and see how this is written, stdio.h, this is something which I'm trying to write it in stdio.h, which is void cat star. This is void star, any data, or maybe like let's consider int star for integer type. So likewise, you have it for anything. Now the whole idea what we did is we went ahead and invoked the function. But in Java, we don't do this. We have a different approach for doing it. So here, every job, when it comes and goes, will be treated as if it is a byte, as if it is a byte. So to understand this better, here is a story. This is the same old diagram which probably we had constructed some time back in our discussion when it comes to our first few classes of our discussion. The end user, if you want to send the data to somebody called as JVM, he will not have an opportunity to talk to him directly. Rather, it goes to operating system. Operating system pretty much have to keep the data. So what operating system does is it will keep all the data in the form of a buffer. So this is your buffer, or you call it as a RAM. That's a whole idea which you try having. Now every data when you give it, it will just go and sit in the buffer. This is where you have it. Now, if I want the value to come to JVM, they cannot just be poured inside. Rather, they have to be taken in the form of bytes. They have to be taken in the form of bytes. And since we are taking it as a bytes, this can pretty much work in any operating system. You take it like Windows, you take Mac, you take Linux, Sun Solaris. Tomorrow you have any operating system, they can pretty much work. The whole idea here is to ensure that the data which it flows from here to here will have the data to be transmitted in the form of the bytes, not in the form of the function calls. But in the C++ or in the C, when you make a function call called as scanf, this scanf is a function that is not the byte. But here we transform everything in a form of byte. But how does this happen? If the data comes and sits in the operating system buffer, this data eventually has to be given to GB. Rather, what we do is we will invoke somebody called as uh, there's somebody here who is a little intelligent guy who is looking like a tab. He's just like a tab. So what we do is we just have to open and close. Each of this opening and closing is basically a call. Each of this opening and closing is a class. I'll say close. Now what happens whenever you make a request? For example, if you are sending something called as hi, this hi will eventually come and set to this buffer. This need not be high. This could be any complicated thing in the world until you are trying to pass in the array or you want to pass it as a buffer, whatever, right? This will eventually come and sit in the bucket. So on a buffer, whatever. Now what happens if I want to open this opening is one of the method calls which I have, which is called as read, which will read one character. So another guy who's called as read line. Read line. Is that okay? When I say read line, obviously it will go after the entire line till it finds a carrier's return and puts the data in the JVM. But when I say read, it reads one character at a time. It reads one character at a time. When I read, the data comes and keeps it here. For example, let's assume there might be a little problem also here. That is, when I said hi, now the whole idea is I should have hi. Since it is looking very small data like hi, it is good. But if you consider this itself as a very complex data in the world, the problem is the way how data will come may be jumbled here, may be jumbled here. For this, there is a special person who is called as ISR, who is input stream reader. Now, what is my ISR doing it? It will make sure that when the data comes from buffer to the JVM, since I may still run with multiple threads in the world, I don't want this data to be jumbled. For this, I can use somebody called as input stream reader. The input stream reader is a responsible guy to make sure the data is in the proper flow so that the data is not jumbled and I'll get what is being sent from the end user. That's the first thing. On the verge of this, when it comes to uh, item, we have two broad categories. So let's make a list of it. The first and foremost is called as reader and writer classes. On the other hand, we have input stream. The next one is called as output stream. Okay. So where to use what? These two people fall in one category. The readers and writers will fall into one category, and these people will fall into other category. Anytime when you have a text, try using reader and writer classes because they can directly understand ASCII values. When you have videos, audios, images, some document files, in such case, we'll use input stream and output stream. So they pretty much make the data to and fro only in the form of bytes, but reader and writer classes can also help you to put the data and get the data in the ASCII format directly. So again, the choice is yours, what you want to use it. And when you want to use something like images, audios, videos and all, reader and writer classes will never help. They have never been part of our story. Input output streams are very good candidate when you want to go with the blob type, which is large object like images, videos, audios, etc. etc. They can also handle TXT, but not a good candidate again. No, it is good. The text data we keep it in the readers and writers. The rest of it in the world, which comes in input stream and output stream. So what we do is we'll put an attempt to understand this very simple. I'll just go back and try writing a program where I can send the value from the buffer and put it into the Java application. In the same fashion, from Java, I should be able to keep it in a file. Keep it in a file. Let's consider the file is sample.txt. sample.txt. So since we say it is sample.txt, I'm sure that you would have guessed, as we have input stream reader, there should be somebody who is called as output stream writer, and the data has to go and sit in the text file. On the words of it, we'll try writing a couple of them. One to deal with text files, one to deal with images or objects. We have our own objects. You can keep employee or anybody for that matter. And we also introduce a concept here which is called as serialization. I can look for a package which is called as java.io. All these people are written within java.io, which happens to be the package here. So I'll click on this. So here I have the complete set of stories. First and foremost, there are like few classes. One is buffered input stream, buffered output stream. Very cautiously, let's have a look at this. And I also see there's a contradictory method. Do you see buffered reader and buffered writer? So we have the methods for input stream, output stream, buffer reader, buffer writer. So in similar fashion, everywhere you will find input stream, output stream. For example, if you ask me, hey Naveen, what is data input stream doing, but where is reader and writer? No, data input stream is not used for character-based access. They are used for something else. In similar fashion, you have somebody called as file writer and file reader. Somewhere we have a file writer, and I should also find file reader, right? So you also have file input stream, file output stream. Look at this. You have every contradictory method out there. So likewise, you have character array reader, character array writer. When you say character, it is absolutely a Unicode character set. Since it is Unicode character set, there cannot be bytes which you can pass. In similar fashion, there are some good classes here. Somebody called as line input stream. Line input stream is basically a class which is used in case if you want to invoke the data which is there in the Excel sheet. Preferably not Excel, it is called CSV. When it comes to Excel sheet, we're going to use something called as a point, which is Apache API, and I'll show you how to work with Apache API. So most of the industries, when people try pulling the data for automation, they all depend on Apache POI, which is very, very effective. So the whole idea here, I just wanted to give a heads up and show you that everywhere you have stream and readers and writers. So you have input stream, output stream, you have readers and writer classes. So we have to broadly classify anything in the world which comes when it comes to text is in the form of readers and writers. When it comes to non-text, which will be kept in input stream and output stream. That's the whole idea. So here we also have another class which is called as file. So you see here there's somebody called as file. When I click on file, the file is a class which is directly inherited from object. It also has some implemented interfaces. Don't worry really about it. We're going to talk about this in some time, right? So the whole idea of file is not to contrast the file with what we have done in C, C++ or other languages. Here, the file will not create a file by itself. It is only a person who can hold a reference of it. Just to prove the point, let's go back and try writing some program and understand this better. Okay, let's create quickly a package. I'll say com.sted.data. So that's where our work will be. So let's have a class. The class is file example one. Let's try writing a main third, and we try having a few functionalities of the file. So first and foremost, if I say file is equal to new file of sample.txt. If this is our file, if this is our file, when I try execute, let me hover here and import from java.io. When I do this, this object, this object will not create a file. This will only hold the reference of the file. I hope that should make sense. It can hold any reference. And you have to understand very clearly, file itself is an object which is little fancy here. So just wanted to show little heads up. I'll say file. When I did this control space, have a look at this. I can give file the string parameter. That's what we have done it here. File with URI. Maybe if you're looking for the remote file which is kept in the cloud, you can still access, but not with IO package. There is another interesting package which is called as NIO package. So if anybody is interested in writing web-based programming, they should really, really think about exploring your ideas in a package called as NIO. I would still show you for a minute. It's pretty interesting package. So NIO. So here I should find. Yeah, here NIO. So NIO is a package which shows a lot of classes and let me try opening one file. NIO the file is good. So here I have few files and they're all like pretty recent classes. Now, if you look at their story, they are there from JDK 1.7. They're not like old files or old structure which they have. Even for NIO, you have like buffer. So whatever we've been doing it with the buffer, which we're gonna do it, very similar to this. But all these things will happen at web level. The whole idea of having NIO is to work with web level. So here, when I say file, you see here, you can even take parent and child. The whole idea here is to say the overloaded constructor here, this meaning. So let me little zoom it and show you. So here, so you have the path name which access the string. That's what we have done it here. You can give a relative path when you create a relative path, something like sample.txt. This will create a file right in the working directory or right in the class path. Now, this obviously refers to URI, or you can even have a parent child. So, what does this mean? Imagine yourself, imagine yourself, if I have, if I have a new file created, file path is equal to C:// some folder slash. Then, then you may have put double quotes for simple reason, right? Then I can say, okay, this sample.txt will have parent child. The parent happens to be path sample.txt. So I hope this is making clear. So what this guy does is he will have this file which is called as sample.txt in the path. The path happens to be the parent directory. Parent directory is some folder. This way, I can create the hierarchy of the file. So I can go ahead, keep having the file itself as an object, which is based out of different uh, folder structure, right? That's the whole idea. So I'll just delete this as of now. I'll go back. So this guy, what he does is he will just refer to the file. So let me just put the statement. I'll just think as file created. I'll go back and click on play. When I click on play, it should give me an acknowledgement saying that file created. But invariably, if I go back to class path, you see here, even after refreshing, you will not find a file which is called as sample.txt. There's no file here which is called as sample.txt. It is just as is. Makes sense? But now, if I want to create, there are few methods which you may have to access. So file can be little handy. I can check if file.exist. So what does file.exist? This function exists with a Boolean value. So that meaning it will only give you true or false. If the file exists, it returns true. If the file does not exist, it can return false. So here, if it exists, then I'll say system.out.println file already exists. Else, I'll say, oh, file dot create new file. So this guy will be responsible to create a file. So I hope this is making sense. So the file as an object here will only hold a reference, but there are a lot of functions who can do work. For example, create new file. You can delete a file. You can change the permission. You can move the file. Whatever pretty much you can do it in your operating system, everything you can keep it here or do it here. Now, when you try executing this guy will eventually throw an exception. What is that exception? Let's hover on top of this. Here it says IO exception. Now, this exception, which is called as create new file method, which throws an exception called IO exception. Since they inherit from exception, they belong to the category of checked exception. Since they belong to checked exception, it is mandatory that we have to surround it or we have to put a throws clause. I hope you remember this discussion when we were trying to do it in the exception. So now I can do that with surrounding a try catch block. So I'll just select this part of the code and say right click, surround with try catch. Perfectly fine. So this guy makes sense. So what we do is we will say file. If the file exists, we don't have to create it. If not, let's create a file. So I'll right click or maybe click on play. I'll just click on play. So it says file is created. Let's go back here and right click and refresh. Perfect. When I refresh, you look at this. There is a file which gets created, which is called a sample.txt. As of now, the sample.txt file has got empty content. Let me open this. The sample.txt file does not have anything. But of course, this is just a start of it where we tried showing, okay, you can try creating a file. In addition to this, we also want few more parameters. For example, I want to say, where is the absolute path? So what is my absolute path? File dot get absolute path. Look at this. You name the method or name the requirement. There is a method associated for this. Or I want to check is file executable. File dot is I think it is executable. Yeah, can executable. So system dot out dot println is file readable. File dot can read. System.out.println is file writable. So you want to check the file if can it be writable. So only then you want to do some job. So these are some handy places where it can help you to get the file properties. That is why the file attribute is used. It is not for the file reference as what we been using in C or C++ if we come from that background. But for that, we have a different means of doing it. We're going to see it in the next example. So let's go back and click on it. All right. It says that the file is executable true, it is readable true, writable true. So let me just go back and let me change it. Let's right click, go to properties. I'll copy this path, copy, go to this place, and there is a file which is called a sample. I purposefully, this time, I want to make this as a read-only file. I want to make this as a read-only file. I'll say apply, okay. So here, I'll play this. Oh, you see, the writable has become false. The writable has become false. Likewise, I can also try writing delete. For example, the file already exists, so we are deleting. Right? So here I'll say file dot delete. File dot delete. You're just deleting it. So let's see what happens. Since the file exists, since the file already exists, so we are deleting. And you see other parameters, the file was deleted. All others turn out to be false. So let's go back to this guy and say refresh, right click and refresh. When I refresh, you see the file called sample.txt is missing. That's what even in your work folder. Again, go back and try executing it. I should find that file which is called as sample.txt. So likewise, there are a lot of fancy things which you can do it with a file object. So it's more to manage the file. The entire discussion for us, we are pretty much dependent on this object. He is not a wow guy, but he is more of a utility for us. For example, if I want to write a file, if I want to read a file, the file writer and file reader classes have to be pointed to know where the file is. Who will help you there? In such cases, file will come. And files are pretty handy when you want to move the file from one location to other location. And if you want to check any file properties, which you can use it. So in the simplest term, if I go to command prompt, whatever operations you can do it in the command prompt, everything in Java with respect to the files can be done by this object. That's the whole idea of having file as an object. We just do that file dot, just spend a minute, just see this methods. If you want to get the length, maybe there are a lot of scenarios where we want to delete the file on exit. We are good if the file is there on the verge of execution, but we want to delete when the job is done. So now I want to check whatever you're referring, is it a directory or file? So there are a few functions called as is file or is directory. This will give you Boolean value whether to know it is a file or directory. Likewise, so many methods are there. So many methods are there. So here you see, is it a directory? Is it a hidden file? When was the last modified? What list all the files which are there in the directory? There's so many methods. So if you just spend a little time going through this, it will be great because it will help us and in further classes. So now let us go back to understand few more requirements here. So a few more requirements. So we'll just uh, try writing a simple diagram. Assume that I have an end user. I have an end user who comes today and says that, hey, we want to pass a value to Java. Perfectly fine. The operating system says, boss, you can only pass it to me. There will be eventually somebody called as buffer. Now this buffer will help you to flow the value inside the GPU. So this is where you can have GPU. So there will be something like tab, which we have to keep it. So this is where we have to work. On the verge of it, I want to write a simple program. Says that just to get started, it will be reading a data from the end user and putting it to JVM. JVM. This is your primary, or you call it RAM, or you call it heap, whatever you want to call it, right? So now, let's assume that I want to say hi. Now I have to tell user, okay, I have to give you a place where you can enter. This is something which I can do it with a lot of classes. Out of that, one of the well executed method from Java itself, which is more reliable, who's called as buffered reader. Buffered reader. So there are a couple of reasons why I use it. Now, first and foremost, let's understand. Since I'm accepting string, it means it makes very sense for me. I should be using reader. I should not be using input stream. Input stream will try using it, but not now. The whole idea here, when you go to command line and invoke it, it will be a text. For all the text, we're going to use something called as readers. So hope this is making sense. Readers. What is buffer? So all the data, when you try getting it, it should be kept in the form of temporary memory. So all those things will go and store in the buffer. So that's where your buffer reader. Buffer reader is readers are so those people who can help to give the data to JVM. It is as simple as saying I need data to JVM. So for this, let's go back, try understanding it. Let's write a simple. Uh, so here I'll say read from user. So here let's have a main method. Here let's have something like this. I know that I want to take it from buffered reader, who's your somebody like uh, a RAM or a buffer memory. So in that case, I'd say buffered reader BR is equal to new buffered reader, right? Now this guy is asking for reader. So what is my reader? Again, let's go back. Try understanding it. Look at this. The buffered reader is something like constructing this bucket. So you are constructing this bucket, and this bucket is called as buffered reader. Now somebody should help you to read it in GB, right? So who should do that? So this guy is from the console. From the console. Now who is this? From the console here, we have somebody called as ISR. Who's here? Input stream reader. So readers are those people who can help you to read the data. So who are readers? So let's go back here. So new input stream reader. Input stream reader. So now, so where is the input stream coming? Where is the data coming? Is it coming from the file, or is it coming from the console, or is it coming from network devices? Whatever you have to specify it here. So since this is our first program, I want to specify this as a console. So console here by default for our system is system.in. Any input devices which is connected to system. It may be a joystick, it may be the keyboard, it could be some devices. The whole idea here, you just have to refer to one of the system devices, stream it, and keep it in buffer. So whenever you have this nested classes, preferably let's start reading other way around. So system.in, that's where the data flows in. It has to be given to input stream reader who streams the data, then it is kept in the buffer reader. Hope this is making sense. Now what I do is system.out.println enter your enter employee ID. So now I want to keep that data in the end user or prompt user saying that hey, please enter employee ID. For doing it, I will use int variable employee ID is equal to something. Now what is the something? From the BR which is your buffer reader here, when I try taking the data comes in one of the two fashions. One is read, if you have got the character, one is read line. When you want to take the line, it means still the character. So in our case, we will try using read line. The whole idea here is user will enter something like 101 and hit enter. The moment he hits enter, I want to consume that and put it in Java's engine. You have to do that. I'll say, hey, I want to use BR, which is buffer reader dot read line. But unfortunately, if you see read line, if I just hover it, the return type of uh, read line happens to be string. Be very, very cautious when you are trying to make it. The read line method gives you all the data in the form of string. And we have already known why it is string in our earlier discussions because string is a wrapper class. Now, what this wrapper class will pretty much do is it can help you to port any kind of data. For example, string, integer, float, double, byte, char, anything for that matter. So now, if I want to have this assigned integer, so I use additional class which is called as integer dot parse in of this. So what this will happen is I'm trying to have a wrapper class around it, which happens to be parser in, and I want to read it. When you are reading it, there might be a chances there could be an exception. So I can just hover it. So here there could be various options. One is you can surround it with the try catch block or throw this class. So whatever is good. So let's go back and surround it with try catch block. So this is where you have it. Look at this. Uh, you see like multiple catches happening. This is nothing to do with Java. This is just the intelligence of Eclipse which we are using it. So what Eclipse does is it will just understand this line and says that, oh, this line possibly may throw number format exception because we use integer parser, or IO exception, which is a checked exception. It's just to do with Eclipse, nothing to do with Java here. Or if you want, you can go ahead and try surrounding this with try catch manually. Likewise, enter employee name, string employee name is equal to yeah. So I'll say system.out.println, enter. Last one, employee salary, double, double dot, parse double of VR dot. Look at the beauty of VR line. This guy will pretty much give you the string and you can convert it to whatever fashion. You want it as integer, if you want it as double, convert it, and so on. Right? The whole idea here is to accept the data and keep it in the application. So I want to show that. So in order to show that, what we do is we just put it here, employee ID, employee salary. Makes sense. This is perfect. So now let's go back and click on play. Great, it prompts me here. So let's say 101, I'll say Harry, I'll say 3000. Great, it does this all. Probably when we tried doing it in C especially, it was first few statements, but in Java, these are not the first few statements. It needs a lot of dependencies, like exception might occur. You have to understand this. Now, how this data gets flown with the help of you know byte stream. That's what we pretty much tried crafting it here. So we have crafted, made sure that when the user enters the value, it goes to buffer. That is what the buffer reader. So in the simplest word, instead of saying this as buffer reader, which you have constructed, you can even say we have constructed buffer reader. So you can write this is buffered reader. This is where you have. So then the data goes and sits in the buffer reader. So I have to open it. On the verge of taking it, I can use something called as a read line, which will help you to read the data and get the data. When you read, it comes to the application. But make sure that you are keeping everything in uh, streamed way. So streamed way will ensure that the things will go smooth without uh, jumble. So that's very important. Then the JVM obviously has the data. That is where you have the data stored in this variable. Let's go ahead, try writing one more example where we want to put the data to the file and get the data from the file. That's the whole idea of doing it. So on the verge of it, we already have this data. So maybe I can just use the same data with the employee ID, name, salary, whatever we have got from the end user. We want to keep this in a file. So in order to keep this in a file, so what I do is I use a reverse engineering way. So what is my reverse engineering? Where the data should not be taken from JVM. Rather, this time the data should be taken out of JVM, kept it in the file. So here the whole story goes. So maybe this application will be little more uh, bigger. So let's go back. Let me erase it here. This is where we want to erase it, and I want to uh, make this little bigger. Great. So if this is your JVM, if I want to put it in a file, let's say the file which is called as sample.txt. That's our file. Here, I want to keep it in the buffer. Now, you have to keep it in a buffer. From the buffer, you have Again, if you ask me, hey, look at this, Naveen, why are you keeping all these things in buffer? Can't we directly take the data from JVM and put it in the file directly? No, you're not allowed to do it. For a simple reason, whenever the data is going out of JVM, they will always go in the form of bytes. They always go in the form of bytes, and all data in the world will get divided in bits and pieces in the form of bytes. Only then it is. Now, when you do it, imagine if you have 1 GB of information, 1 GB of information directly you cannot send to the file. Rather, you give it to operating system. Operating system has a lot of concepts out there where it does context switch, it does scheduling of a job. It gives you some resources for each processes and so on. On the verge of it, I keep it in a buffer. The buffer keeps filling it. So as in how the operating system allocates time for this application to run, it just pops out and puts it in the file. So it pops out and puts it in the file, pops out and puts it in the file, and so on. This will be a regular process for us for every time you want to put the data to the file. So now I'm sure that you would have guessed it. We will not be using buffered reader. Guy will be called as buffered writer. Buffered writer. And this is a file, sample file. Let's go back and try it. So here we'll try writing a small snippet of code to write the contents into file. So preferably we'll use buffered writer. There is another guy whom we can use. One happens to be character array writer until it is all treated in the form of characters. But anyways, the buffered writer is somebody who's really handy and it has a very good performance over other classes. So I would say buffered writer BW is equal to new buffered writer. So let's override import. So you may have to import it from java.io here. So now buffer.writer will do a control space. It takes a writer object. It takes a writer object. So here, how do I give writer object? Now we have to figure it out very cautiously. What is my writer object? Where do I have to write? So now my idea to write this program, I'm sorry, here the whole idea here was to write it in a file. So I should find a class which will take the value of buffered writer and put it here. What is this called as file? So what is this called as file? What is my file name? File name. Here I'll say file. File is equal to new file of a file which is called as sample.txt. Or let's call it employee.txt. That's what we want. So let's hover this, import it. So here, someone should be there who takes the data to the file, and we know what is the file location is. He is called as FileWriter. Is equal to FileWriter equal to new FileWriter of file. This meaning I will use a class which is called as FileWriter to this file, and the data to this FileWriter will be given by BufferedWriter. So which will be FileWriter. So I hope this is making more sense. So you first have to create a file or first reference a file. The file writer has to create a file and it should help me to transport the data from Java application to the operating system. Now, this responsibility is carried out by somebody called file writer, and the data where file writer has to look for will be kept in buffered writer. Now, I will say BW write. So when I do write, there are various options which is possible, various overloaded methods which are possible. One happened to be sending the string by itself. So I can take the string, I'll say apply ID happens to be API BW data write, apply name, API name, bw.write employee salary. So here employee salary. Makes sense. This is awesome, right? So we can keep this uh, right, and let's go ahead and let me just put a message outside all the story. I'll say data saved successfully, right? Data saved successfully. So let's click on play and check if things go well. I click on play. Uh-oh, it has an error. Error. Here there is an error. There's a small red dot. I'll click on this. Probably I missed a semicolon, right? So let's click on play and say, okay, it asks for employee ID 101. I'll say CV. I'll say 3400. All right. So it says the data is shown and it says data saved successfully. Let's go back. I'll right click, refresh. When it's a refresh, there should be a file in my case which is called as emp.txt because emp.txt is the file which we were planning to construct. The file is created. That's very nice. Let's open this. Oh, there's something gone wrong. I don't see a data, right? Now this is a common mistake most of us will do it. So the data will not be visible. So in order to make it visible, let us think, having a look at this code very cautiously. Now what happened? The file is open. So this is your file opening procedure. File is open in the file writer. The buffer writer takes the data. This is where your processing is. You should also have bw.close. bw.close. What is my bw.close? So that every file, when it opens in the write mode, it is kept in the heap. If you want to persist it in the secondary storage device, then invariably we have to say close. Only then the data is stored in the file. Is that okay? So now let's go back and say close. I would say play 101 CP 34. Great. So let's refresh. Yeah, refresh. I'll go to employer.txt. Wow. I see that the data is kept there. Likewise, I can keep going and adding as many employee records as possible. You can always write bw.close here, perfectly fine. I'm not denying it. But if you ask me, that's a bad procedure. What happens if there is a problem in processing? The close will never get an opportunity and the file will never be closed. Since the file will never be closed, the data will not be persisted in the file. In order to do that, you have a next block which is called as file. So this is where the real need of finally comes into picture. So I will have to copy this or cut this and paste it here. But BW is not recognized. The whole reason behind this, the variable called BW is declared within the try block or within this uh, curly braces. So the scope of this will be only within this. So what we do is we'll take this guy out. I just little move it. Correct. I moved it up. So here, since it is outside the try, so that this variable scope is available even outside the try block. And creation of an object, the good idea as a good developer is you don't have to do it here. I will do it inside. So here, initially it will be null. The file writer will be initially null. The last one initially set it to null and paste it. So what we did, we declared this variable outside the try block so that the variable is visible even outside the try block because we want to use it in a file finally. So I'll say file is null, file writer is null, buffered writer is null, and instantiation will happen here. So we have to say something like references are construct. References are here. Here, the instance is constructed. Make sense? The instance is constructed. Then obviously, as this guy, bw.close should be there. And look at this. Since this bw.close is within finally, this bw may also throw an exception. Also throw an exception. Now let's go back, right click, surround this with a triangle box. Perfectly fine. That might throw IO exception. Now this will be a very good program for our understanding. Look at this. It's pretty clear. It's pretty clear. So let's go back now and say play as a 101. Uh-oh. Okay, I just put the name as name. Sorry. Salary as like something like the 3434. It gives you number format exception. Probably we should have executed once again. 101. Uh, I'll say 3434. Great. So the data goes very well. So now I have to go back and check this file, employee.txt. You see that employee ID 101, employee name Ashwini, employee salary 3434 dot o, perfectly fine. But where is Sibi's record? Now I started missing the older record. Now what happens by default? The file writer will eventually start overwriting the file. As you put the new data, the older data is taken out. Just for example, I'll go back and click on play. Here I would say 101 Kumar. I'll say 2323. Go back to the file and open it. So I don't see Ashwini's record. So make sure, in case if you want to append the data every time, here you have a file writer, the file writer object. So let me just go back and do a little control space just to show you, just to show you the control space. Here, the third overloaded method call will say Boolean append. So I can either pass the file or the string of the file, and I can give the append mode, which is Boolean. So if I by default it is false, if you say it as true, it starts overwriting it. So let's go back and try doing it. Since we already have a file, I'll select this. The file happens to be the file. Append is bw dot new line. So this guy will put a new line, bw dot new line, and so on. So here also bw dot new line. So this will just enable us so that the data looks pretty neat. So let's do that. I'll click on play. So I would say 101. Let's say Ravi. I'll say 45, 45. Great. Let's play again. 102, 50. I'll say 46, 46. Great. So here, when I open the file, right. So the whole idea here is data is getting appended and they're all put in different lines. So this is where, of course, it was a previous data and it looks pretty clean now. So any data from here afterward which goes into this will be appended and it will all be kept in new line. For example, I'll say 103 CV, let's say 4455. I'll click on play 105 5543. So here you have complete data. Now, trust me, it is as easy as this. It is just as easy as this. to work with any classes in Java, any classes. So if you want to write the text, they're like pretty much same. This time you are an end user, but you want to store or you want to pull the data from the file or you want to store the data to the file. So let's assume this. You have the same old story. So somewhere here you will have JVM. So or you call it the simplest term who's called as Java. So what I want is I want to put some data, but this time it is not a text data. It is some not text data. For example, if I have a class which is called as EAP, EAP will have its own properties, and I want to take this EAP. Of course, I can create a bean class and keep it in Java, and I want to keep it in a file which is called as uh, something like sample dot. There is something here. Don't worry, what is that? Dot as what it is as of now. But the whole idea here is if you see the way how we are constructing the employee, in the employee, you will have a lot of fields. Something like employee ID, employee name, salary, they can have photo, their date of birth, blah, 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 1,001 details. This has to be got into Java and it has to be ported. And we know that since it is not text file, we cannot use something like readers and writers. We should be using something like input stream and output stream. So since we are sending the data, it will be output stream. So hope this is making sense. In the output stream, when you try sending it, we know there's a hard and fast rule here. Every time the data gets ported, it has to be ported in the form of bytes. It has to go in the form of bytes. It cannot be in any other fashion. It has to go in the form of bytes. But on the verge of it, when you go in the form of bytes, this object which you are trying to send it, which is employee object, this object, when you are trying to send it, it has to be broken. Imagine if the size of the employee object is about 25 MB, each employee object. Now 25 MB cannot go here in one month. No, 25 MB cannot be ported in one go. Rather, it has to be broken down into bits and pieces. Somebody has to give a stamp to say that, okay, you can go ahead and break it. Somebody has to give a stamp. In order to make a stamp, you are acting on a class which is called an employee. The employee class should be okay to stamp it. So, how do you stamp this class? There is a special method or special implementation which we have to do it. Now, this implementation is called as serializable. Just to give a little heads up on serializable in a common terminology, imagine yourself, imagine yourself if you have if you have somebody here called as Java. I'm trying to say this is completely Java's scope out there. This is completely Java scope out there. You have employee class, you have employee class, and you are assuming that you are inside JVM. You're using it here, no problem. You're using it here. So you put it here, absolutely fine, no problem. You don't have to take care of much thing. That is what probably we have done it from day one. We tried creating class, all these classes which we wanted, it is all kept in the JVM scope. But now the idea is to send it outside. If I want to send it outside, that's a question. How do I send it? Can I take the employee object and keep it and send directly? But Java will not believe in it. If there is no guarantee the kind of classes which you are writing is a simple class. Rather, this may be the heavy loaded class, something like hundreds of MBs. It says you can send it, but you have to break down this into bits and pieces. This breaking down as bits and pieces is called as serialization. This is called as serialization. There is an interface for this which we have to stamp it called as serializable. The interface serializable is called as marker interface. So this interface is called as marker interface. Now, what is this marker interface? Imagine yourself there's a interface which these people have written from Sun Microsystem, which looks similar to this interface. That's it. So there's an interface. There's no method. Nothing. The interface which does not have even one method are called as marker interfaces. One of the very widely used interfaces in the world when it comes to data transformation is called as serializable. If I have a class here which is called as employee implements, this meaning we are stamping the class employee to be broken down pieces while transporting. That's it. That's a whole intention of having serial. If I don't have this meaning you are not allowed to break this into bits and pieces, and Java does not believe, because when you are putting in the file, it is always required to send the data in the form of bytes. If you want to send it in the form of bytes, you have to break it, or you have to make sure this is implementing serializable interface. Imagine you have visited a restaurant. So when you go to restaurant, so you order for some nice dish. So this guy, what he does when he gives a dish, he will arrange everything into certain way. He gives you the nice plate. Now there's a decoration, blah blah blah, kind of thing. But now you say that, hey, bartender, now you have given good. I don't have a problem with this, but I want to make this as takeaway. But if you want to make it as takeaway, the bartender will not give you this plate. Rather, bartender will cleanly take this and pack it in a nice bag and give it. So when you go home and if you want to eat, so again you will open it, you will make a very similar arrangement here. Now, the whole idea here is here. Can I pack? Can I make this as takeaway? So if somebody has to stamp, this stamping is called serialization. This is called as deserialization. So it is many times we call it marshalling, unmarshalling. So marshalling is wrapping this into bits and pieces because it's in a bag. Since it is in a bag, you can carry however you want. And if you want to take it out for eating, you will do something called as unmarshalling. So on the verge of it, we will try using one of the classes very widely used in our discussion, just object output stream, object input stream. As the name says, we are trying to deal with serialization. Java believes to keep the file in the .ser. Again, there is no hard and fast rule that the file should have an extension .ser. Preferably go with SCR because everybody in the world are trying to do it. Now, if you say, hey, Naveen, what happens if I use it as .txt? Will it store it as .txt? No, there is nothing called .txt which it stores. It will just stores it in its own fashion where it can be decrypted or read back in the unmasked way, which is deserialized way. If you give an extension as .scr, then if not, you're open to give any kind of extension. I can give my name as an extension, right? The idea here is I'll have a class which is called an employee, which I have to get it in Java. Once I get it in Java, I want to send it to this guy who's serialized. So this will be called as output stream. And what are we sending? We are sending an object. When I send object, you can send anything meaning anything. So this will be object output stream. If you want to read it back, you have object input stream. That is where we can pretty much try having a readers and writers for object. So this can be any file or photo or video, audio, anything for that matter. So now let's go back. Try writing this program. I'll close this guy. I want to create a new class. We can use something like employee, or it could be uh, anything apart from employee. Let us consider uh, something like uh, products. Products. So every product will have private int, product ID, private string, product name, private double, price. So here, I want to go back to source and generate getters and setters. Say select all and say okay. That's the first thing which I've done. Plus, I also need the constructor using fields just in case you know if we don't like to use setters, we can go with this. And I also need something like toString. So instead of using getters every time, we can pretty much do this. So if this much is done, we have not implemented serialized, but let's see the error part of it first. As first see the implementation, then see the error, then let's fix it. So I want to create a class here, which is called as store get object. So I want to store and get the object. So anyways, we will have this guy who's me, but I also want to introduce few more people. The first guy happens to be public void store store product. So products. So that's our class. There's the next guy who is public products get product. So you're not sending any parameter, you're just saying, okay, get me all the products. So as of now, just to avoid that error, I just put it as return null. There's no harm in it. So this guy will say, okay, I want to create a products. I'll say product is equal to new products of what it is. I'll say 101 monitor. I just put like 2000 or 2000. Perfectly fine. So now I want to invoke this guy who store product. So I just make it public static so that I don't have to create the object really static. Makes sense. So here I can say store product and product happens to be product. Okay? We are invoking this method and sending this product here. So it gets ported here. Once it ports, now I want to store it in the file. So here we will write the business logic to store it into .str file. Great. So who should help me to store? Because object output stream, because we are storing an object, we have to look for output stream. I'll say object output stream control space, it will work. Or if you really like it, I like this way. I can use something like OOS. So I know the file name is our class name is object output stream. So the way how we construct all the classes in the world are all in the Pascal casing. So I'll only take the uppercase characters which are there in each of the class. Something like object output stream here, output stream. For this I use OS. So this will be O O yes. So Eclipse will internally identify. Tomorrow, if you are writing a class which is called as employee salary processing, you just write ESP control space that will give you full filled class, most appropriate, right? So because I took E from here, S from here, P from here, ESP control space. So that's what I do with OOS control space, and it's all done. So I'll say OOS is equal to new object output stream. It needs an output stream. Somebody has to help, right? So somebody has to help you take this data. And we know that last time we tried using FileWriter. This time it will be new file output stream. Where is the file? The file is here. File is equal to new file of product.scr. Right. So let's hover import. Great. Where is this R0 coming from? Where I can put the file. That is so nice. So this guy eventually will throw an exception. The good idea is we just surround it and select this code and right click, surround it with try catch. Good. So there's a try catch block. So in case a file is not found and if there is IO exception, that is caught. So once if it is done, I have to store the object. I will say OS dot uh, write. So when you invoke this write method, there are various overloaded that's possible there for storing the data. So you have somebody like object, you can write the byte, you can write the int, write the boolean. You can only write array of bytes, write integer value. So you can pretty much try writing anything you want. So object can take you anything. So I can say write object. When I say object, I don't know. I don't know what object it is. It could be employee, it could be devices, it could be products, or it could be something else. The whole idea here, since it is not a primitive type like int, float, double kind of thing, I can go ahead and choose to have somebody called write object. So when I write object, I have to tell what is my object, which is product. So once after this is done, I can just say system.out.println uh, object store, object store. So in addition to all the things, I'll just put one more important information is dot close. Right. So this will ensure the data is stored. The data, the data persistence will happen only when you close it. So let us do a little work and click on play and see. We have already done some work. Let's click on play and check if things go well. I'm sure that they should give an error, and we all know what is the error. So it says that, okay, object is stored perfectly fine, but in reality, there is an exception. So let's read out an exception. Java.io not serializable exception is thrown at this class, which is called as product. So did you see this Java did not even take risk of storing the object. It says that I don't want to look what size the class is or what size the object is. All I need to know is that class eligible to be serializable? If it is, then go ahead and store it. So to make sure this goes and stores in the class or stores in the file on the class, we have to have implement serializable. This will be a kind of step for every class to store and get the data. So let's go back and click on play. All right, it says object is stored. Let's go back. I should find a file which is called as product.scr. Let's refresh. I have a file which is called as product.scr here. Let's double click and look at this. This data is not visible by human eyes. It's not something which is really visible. On top of this, there are a lot of cryptography algorithm people write it these days. But our discussion here is to know how data goes, how the object is stored in the world. That's where the entire story is. And one important thing. So as the OOS or your object output stream can pretty much store anything, be very cautious to store it. So you have like various writer methods, write object, write int, write double, write byte, and so on. Imagine if you are trying to store integer, float, and devices, like or products. In such case, imagine the devices is the first object to store, which is of let's consider 20 MB or 20 bytes or whatever. You also have somebody called int, which is getting stored of 4 bytes, right? This is capital B. If I want to store something like double, which is 8 bytes, and so on. If the data goes in this fashion, you have to exactly pull the data in the same order. You cannot jumble it up. You cannot say, hey, look at this Java. Can you give me the double first? If it gives double first, then what happens? It will give you part of the data. It will not be full data. In similar fashion, I cannot go ahead and try taking in, and I cannot get the actual object of the products at the last. The object output stream, you have to be very cautious. Now, when you put the data and get the data, you have to put the data and get the data in the same order which you have get and put. Because if there is a mismatch out of this data, part data is given, and by now, this is a correct data because it does not suffice. Be very cautious. And that is one of the reasons where we don't use extensively what is called as serialized concept. This is used in some cases because they all get cached and they are very faster also, right? Let us do that. Let us do that. Here, I want to show you I'm writing a product OS dot write. So I want to use the write int. I'd say 101, right? Uh, let's put double or maybe like character, whatever. I can even write object, say hello. So this is perfectly fine. So let's click on play just to make sure that we have put some data. The object is stored. Very good. But I want to read the data. Now, in order to read the data, we have already constructed a method, and this method happens to be get product. So here in get product, let's go and delete return null. So here I'll say there's a file. Of course, file you don't have to really write it. I'll go back, copy this guy, and put it here. So here I'll say object input stream OIS object input stream of file input. It will not be output stream now. It will all be input stream of the file which is called as file. So we want to read it from the file. So I hope this is making sense. So the good thing is since it throws an exception, what I do is I'll quickly surround this with try catch block. I surround it with try catch block here, here. I want to read. So how do I read it? The OIS dot read object. So when you get read object, the first object is given. What is the first object which you have stored? Which is product. So you have to retrieve it in product. Products, product is equal to this. Since it is object, you may have to typecast it. You have to typecast it. So this will also throw an exception. Let's put an exception which is called as class not found exception. Class not found exception. So there might be a mismatch in the class not found. So that's a whole idea. When you try taking the object and you're casting it to products, this may be the wrong class as well. For example, if you read first string and put it here, then there is a problem. Right? So the next object which we want to get is int. So I'll say, hey, I want int is equal to os dot read int. The next is okay. This is my int. Here I'll say string str is equal to reads dot read object. Read object. You have to typecast it. Add a typecast. Okay. So now uh, product. That's what we are printing it. System.out.println. This is details. This guy is int value, which is my int string value, which we want to get is str. Makes sense. So just to keep compiler happy so that it does not trouble me every time, I just return null. So in case if there is an exception, that's a whole idea. And you're printing it at the same time. I also want to return product. We're printing it, of course, and we also want to return it. So let us go back here and comment of the store product. I want to invoke a method which is called as get product. So get, and you have to understand very cautiously when you wrote it in this fashion. You wrote product first, int second, string third, and how you are taking it. Product first, int second, string third. So let's click on play. All right, I've got the data. Perfectly fine. Sounds good. It has got the right data. But on the word, in case if I take this string and put it at first, so I'm not doing anything. Instead of product first, we just put string first. Let's see how does it behave. Okay, so it says the class cast exception cannot be casted to string. So what would have happened? The same old story of our discussion. So the first object was supposed to be product. The product was supposed to come, but unfortunately it took string. It would still give, it will be a partial product. This will eventually land up with class cast exception because product cannot be typecasted to string. Thank you for watching. See you in the next video.